All right, sorry about the delay, folks. Just dealing with some other technical issues today. My computer is just unreasonably slow at the moment, also. So, par for the course. Sorry, I'm going to turn my. Let me know if I need to turn up or down. If it's peaking, just let me know. Let me get Slack up on my phone here so I can monitor a basic prep channel for questions. And do feel free. I've talked to a few people recently that have mentioned that during streams or class, like they don't want to like bother people with questions. But I will say that I really enjoy taking questions, and I think just from my experience, it just when people ask, it seems like other people will tend to have similar questions. So you're probably asking on your own behalf, but probably also asking a question, or very well asking a question that could be helpful for somebody else, and that's always. Um, all right, so let's get to it. So I think we left off last time we did some stuff with, or last time I led stream. I'm not sure where Tovio is, but I'm just going to continue off on the schedule that I left off on. So last time we covered some Python basics, as well as, where was it? Strings, was it? Where is it? I can't find it. We're going over for loops a little bit, so that's fine too. Um, and we'll go from there. But I guess we can just pick up. Let's just pick up. What's this one? Okay, assignment and incrementation. Okay, in Python and how to use variables in basic mathematical operations. Cool. Oh, can I turn on? Oh, I don't have dark figure in here. All right, that's okay. So let's just look at this real quick. If you're joining from premium prep class, we've probably already covered this, but it's worth talking about because there's a few little pointers here. So, yeah, I guess we went over. Well, let's see. Just want to make sure I'm not talking about something that we haven't gone over yet. That's not represented in the material. I mean, so we're talking about assigning to a variable. So standard Python naming convention. If I have a two-word variable name, two words, um, we'll use an underscore to separate the words. A lot of other languages will have a camel case, or I think this is this. Yeah, this is camel case, and then this is Pascal case. But Python, kind of as the name implies, uses snake case, which is where you have the word separated with an underscore. And then we'll say equals, and then some value. We'll just do 64. Cool. So using variables in mathematical, wherever I say the name of this variable, let's say, let's just call this my var. My var. Wherever I use the name of this, it will actually just refer to the value that I assigned to it on line 4 here. So let's go for, let's just print this out. Okay, down here. Do a quick sanity check. Oops. Can actually run it. There we go. Taking a second there. We'll give it a second. Okay. It's gonna take that long every time. print out 64? Oof, that's a weird issue. Gonna have to troubleshoot that later. Okay. All right, so wherever I use the name of this, you can see, even though my interpreter is being really slow for some reason, it's going to give me that value. So if I wanted to do 64, or whatever the value of my var is, minus 100, we'll save that and run it. And it'll run eventually, promise. I wonder, do I just have some like code somewhere that's just running? That's just wildly long. So anyways, so 64 minus 100 is going to be 36. Let me just check this out real quick, make sure I don't have any live code here that's going to be slowing things down. These two, I don't know if that's going to help. I don't think that's going to help anything, but whatever. Okay. Well, let's see what this lesson has to say for itself. You've seen variables in a few of the previous lessons. The next unit will cover variables in much greater depth. The purpose of this lesson is to introduce the concept of variable assignment. Yes, okay. Which is performed using the assignment operator. So this is a single equals. There's another operator that uses two of those next to each other called a double equals. That's the equality operator. Single equals is called the assignment operator. So sometimes I'll read this as equals, but this can also be read as assignment or as gets. Sometimes I'll say gets. So the way you might read this var equals 64 is var gets 64, because you're assigning the value 64 to the variable name my var. So assigning values to variables always, allows you to reference values by name and store the result of the results of expressions for reuse. I might reword this as and store the results expressed for reuse. So this kind of code right here, this kind of this bit is called an expression because it expresses a value. It's literally gives you something back, right? So if I say my var actually is all by itself an expression because it expresses the value 68 as 36. It expresses the value 36. And then we print out whatever the result of that expression is. So that's what's being said there. Naming conventions, we kind of went over that. Using the underscore to separate words, that's a standard and well accepted naming convention. Naming conventions for variables will be learned more extensively in upcoming lessons. For our purposes here, x, y, and z, and other similarly named variables will be used to store numeric types. Connect to this REPL to run code example in this lesson. Let's see what that REPL has to say for itself. Let that load for a second. Variable assignment requires three things: a name, the assignment operator, that's that single equals, and a value, something to assign, right? So you can see we have that here, right, in this code example. We have x, which is an arbitrary name that we give it. We could give it any name there. And then equals, saying that we're assigning something to the name x. And then 7, which is some some data that we want to assign to the value x, or to the variable x. Oof, let's see if this will actually log me in. Not sure why things are being so slow today. That's so funny. Okay. So slow. Sorry about that. I'm sure you probably can't see that too good. Let me. That's better. Okay, you should be able to see that. Sorry, my text editor keeps going white like that. Okay. So simple variable assignment, we have x equals 7. If we print x, we're going to get 7 on that line. We can assign something to anything that's going to express a value. And what's going to happen here is y captures the value that is expressed at this time, right? So, oops. So y captures whatever the result of this expression is. So 521 over 74 plus 7 to the 1/8, which is going to be the 8th root of. There could be some more parentheses in here to explicitly define order of operations, but it's just, this is just to make it clear that we can have any kind of arbitrary operation as long as we end up, whatever is we're assigning to is actually going to express a value, then we can assign it to a variable. So if we print y, we're going to get whatever the result. We'll get some output to go with it. We get a lot here. So that the result of y there is going to be this 8.3159 because 7 was before it. Oh yeah. We can refer to other values. So notice here we created x on line 5 with 7, and then on line 11 we made y. So we can use those values and assign them to another variable z. So we can do x plus y over 100, for example, and that's the value of z. Something I want to note here. If I say, let's say I say x equals, we'll just do this with really little values here. X equals 2, and we'll say y equals x plus 2. So y should be 4. So if I say x equals 10, if x equals 10, and I print y, just to be clear about this, this is not asking y to evaluate, x plus 2 with the current value of x. On line 5, y receives the value 4 because x is equal to 2, and we add 2 to that, so that's 2 plus 2 is 4. So y gets 4, which is whatever the result of this is. And then this change in x on line 6, that's completely independent. That has nothing to do with y. And that's not going to affect the value of y because it happens after y already acquired its value. So let's see if this is going to run in a reasonable amount of time. Well, you should be able to see that. We'll get 4 out of that. It won't actually change the value of y. Cool. Awesome. So we can override or aka mutate the value, or we can mutate the variable. You'll hear the term mutate, and that just means to change its value, right? So we can change the value of z after it's been created. And Python has no special rules about this. It just you know, to create it, you create it with the single equals, and to change its value, you just, it's like you're declaring it or creating it all over again. And yeah, that works just fine. Yeah. So incrementation. So I actually want to give you a little bit of a different example on this. So let's say, we'll start with x equals, yeah, just x equals 2. That's simple enough for now. And then we can do something, so this would be an incrementation pattern. X equals x plus 1, right? So this is something you can do. Just realized. Is my font okay? Does that, somebody put it in chat if I need to increase my font size on my text editor. I always like it really small and worried if people can actually read it. I'm going to keep it this way for now unless somebody wants me to blow it up. Okay, so this is an incrementation pattern where we initialize a variable and its starting place can be anywhere. Often when we're doing an incrementation, we're really starting at like 0 or 1 or some neutral value. We'll just start at 2 just to kind of demonstrate this. So you can reassign an existing variable to an expression that it includes itself, but obviously if I say x equals x plus 1 and I don't have some other value to plug in for x, it's not going to know what I mean, right? So if I run this, it'll take forever to run because that's what it's doing right now. My interpreter seems to be in a mood at the moment. So if I run this, I'm going to get an error, and it's going to say x is not defined, right? And this is kind of funny because I'm defining it right here. So that's why I have to define it before. That way, the expression on the right is valid, right? So if x is not defined first, then this expression on the right-hand side is invalid. So if I run that again, x equals 2, x equals x plus 1 is going to be 3 because x is 2, so 2 plus 1 is 3, and then the new value of x is based on the old value of x. Oh right, I'm printing y, that's why. All that time just to get an error. Cool. So this will give us 3. So this is such a common thing to do that Python, as well as most modern languages, have just a shortcut, kind of a shorthand way of writing a line like this. So if I want to add 1 to the current value of a given variable, I can say x plus equals 1, right? And I don't have to use the plus here. I can use any other mathematical operator, and it will also work. But we shall see. Cool. So that's going to be 4, right? So what happens here with the syntax on line 6 is Python looks at this and it sees the plus equals and it says I see, so I'm going to add 1 to whatever the current value of x is. And it literally, behind the scenes, it changes this line 6, into line 5. It literally like transmutes it into that behind the scenes. Just like that. Okay, and this is showing you incrementation as well. Right, and this is what I was getting at. So we don't have to just use plus equals. We could also use, let's say I wanted to write a line that says x equals x times 3. And it's also worth noting, like, I can do plus equals 3, and it's going to add 3 every time, right? But if I wanted to do x times equals, that would turn into x equals x times 3. Should have ran it. Wow. Okay. That's for x plus equals 3. Oh no, that is for times equals. Wow. Such a long delay. Okay, whatever. We have the same thing with division equals or slash equals. I'll usually read this as slash equals. So that's b slash equals 3. And it doesn't show the other ones, but you can do minus equals, you can do star star. Okay. So the memory location of n changes when the variable n is incremented. So memory location n changes when the variable n is incremented. So this is going to show us, if we start in at 27, we'll print in, we'll get 27. Actually, let me just copy this in, because let's just see this run. So this is talking about IDs, right? We're introducing a new concept on this line, potentially a new one, at least new in the if you're at this point in Learn, right? If you're in Premium Prep, we probably talked about IDs. I tend to kind of gloss over them, but I probably shouldn't do that. So the ID gives you a reference to a memory address. So if we look here, we do have a request to increase the font size. There's 3 points up. We'll do that. Oops. Actually, I'm just going to leave it at the same size so it doesn't mess up my shot composition there. Hopefully that'll work. Okay, good. Okay, so an ID is going to give you a reference to the place in memory where that variable is held, or at least it's an unique identifier that's assigned for every variable and everything that needs an ID in, or excuse me, every value. It's the value that has the ID, not the variable. So here we create a variable n equal to 27. We print out n. We see 27 right there. That's the first thing we have printed. And then we print the ID of n, which is really the ID of 27. And that's going to be this number here. So a lot of times when you're looking at an ID, if you're looking at two IDs to see if they're the same or if they're different, it's easier to tell if they're different by looking at the last few numbers. Usually even the last 1 or 2 numbers is going to tell you whether they're different or not. So you can see on the left, both of these IDs start with 430, but the way they end is pretty different. So from right to left, it's 029 and 259. That's really confusing. So the last 3 are 920 and 952. So they have slightly different IDs. And that tells us that when we change the value with an integer, when we change the value in the variable, it now points at a different place in memory. It points at a different integer. And this tells us that the way we're using this integer, we're not mutating the integer itself, we're just at where the variable points, right? So it was pointing at 27, now it's pointing at a different integer in a different place in memory, which is going to be 28, right? Cool. If that seems a little weird, like how does that fit in? Don't worry about it too much for now. Just know that is the case. You know, it'll become someday. It'll become clear. I should think of a good example for why that is. Incrementing values. I think we went over that pretty good. That kind of gives us what we saw before. Yeah. So this is saying what I said before. I'm going to just read it again. So an incrementation operator, that's referencing like a plus equals or minus equals or slash equals, or these are the various incrementation operators. An incrementation operator just refers to the combination of an assignment operator and some other operator, some other mathematical operator in this case. Such as the expression, like I said before, they're into x equals x plus 1. It literally changes that into the other one. And either form can be used, although you'll usually see the shorthand way because it's nice. It just makes for a nice readable code. The incrementation operator is a form of something called syntactic sugar, which is just, it makes something a little sweeter, right? It makes it a little nicer. It's like putting syntax sugar on your Python. It takes this kind of slightly ugly statement and makes it just slightly prettier. So, yeah, and it only serves to improve the appearance of the code, but the functionality. So here's the thing, right? Variables only reference values. They are not values themselves. So, and you'll probably will hear us break this rule in just talking about variables and values, or you may, but the in itself is not a value, right? So it's, I think it's safe to say that you will hear people like refer to the value n or the value of n, and speak like that, but it is technically incorrect, and it's worth, even if you talk like that, it's not a big deal, just so long as you do understand that in itself is not the value. In is a variable that has a value. The value is going to be the, in this case, 27 or 28 that it points at. And this talks about the ID function. Let's see how this explains ID. When variables are changed by incrementation operator, for example, the location in memory to where that variable points also changes. Okay, so the location in memory where that variable points also changes. So that's saying it points to a different location in your RAM, in your program memory. The following example demonstrates this behavior. Using the built-in ID function to show the values associated here. And like I said before, that's going to give us these big, long integer-looking numbers. Here's a good opportunity. When I want to know something about Python, I tend to think about, like, how can I get Python to tell me this? So I'm pretty object. That would be an error. Oh, someday. That is what I would expect it to do. Good. So notice how the ID of the variable in is not maintained when the value sort of one of those like, yeah, of course, like why would it be that way? For those of you who have played around with lists, let's make, so we know with integers, if the value changes, the ID changes. But where this really sort of comes into play is, let's say I have a list equals a list, and I'll just say, we'll just put something in it. And then we can do print, print ID list. We'll print the ID of the list. And then if I change the value of the list, if I do list.append, some value, doesn't matter what. So you might think, well, the value of the list changed because you appended something to it, and that is correct to say that, right? But in the case of a list, changing a list this way does not actually change the place in memory where that list exists. So it's still literally the same list, right? So 27 and 28 are different numbers, not just because they're different numbers, but they have different IDs, right? Whereas the list of 735 and the list of 73557 in this case have the same ID. So that's kind of a funny thing. If you haven't gotten to lists yet, and this is a little weird, lists will come up fairly soon, and they're not that. Don't be intimidated. Don't let them. Don't be scared by them old lists. They're not that hard to deal with. Cool. But that's really where I think the understanding ID kind of comes into play. Is like some things change ID when you modify them, and some things don't. And it really sort of, the way I think about it, has more to do with the value than the variable. Like that sort of bears more on the type that you're dealing with, the type of data that you're dealing with. So in this case, integers, we change an integer in a variable, it's gonna change to the same. Cool, challenges. Did I miss anything up here? Notice how the ID of the variable in is not maintained when the value of in is modified. This implies that in itself is not changing, but is instead being pointed at a different value in memory. This touches on the concept of mutability and is explored in greater detail in the next unit. Get a little light in here, sorry. So assignment and incrementation challenge. What is the value of x after the following code executes? We start x with the value of 10, and then x plus equals 2. So remember, that's going to change to x equals x plus 2. Obviously, that's not the answer. But if the current value of x is 10, then 10 plus 2 is 12. Therefore, x equals 12. Let's try that. Yay! I did basic addition. Cool. So first x is assigned. First x is assigned to the value 10. Then the value of x is incremented by 2, resulting in 12. Here, the plus equals operation is shorthand for x equals x plus 2. Oh, mom. What is the value of y after the following code executes. This is so funny looking. So y equals 8. We'll start with that. So y modulo equals, there's probably a really cool use for it. So y equals the current value of y mod 3. So the current value of y is 8 mod 3 is 3 goes into 8 twice with a remainder of 2, so that's 2. Okay, and then y star equals, how would you say that? Exponential equals? Exponentia equal, there's something. Okay, y star equals 2 is going to be y equals y to the second, right? And remember, the new value for y is 2 because 8 mod 3 is 2. So we have 2 to the second, which is 4. Yeah, jeez. I'm doubting myself on that one. Okay, so first y is assigned to 8. Then y is assigned to the result of 8 mod 3 because we did mod equals 3, which is 2. Then y is assigned to the result of 2 raised to the second power, which is 4. Good. True or false, does the ID of x change when the following code executes? I'm just going to say yes because I see we establish a value and then we change the value. Correct. Here the operation, no, don't, oh, Chrome, no, Chrome. I keep doing this thing where I think I can accidentally scroll left or right. And in Chrome, that's like a shortcut to go forward and backward. I keep doing it all day. I've been doing it. I should just find it in the settings and disable it, but really I haven't. Okay, let's check it again. I don't want to read that. Okay. So here, the mod equals operation is shorthand for x equals x mod 2. So 5 mod 2 is 3. Excuse me, 1. So x is being reassigned to point to the value 5 mod 2, which is 1. Since x previously pointed to the value of 5, its ID changes when we change its value. I already did that. Cool. Comments. Utilize 2 types of comments commonly found in Python. Well, I used one of them right here. Comments are useful. They are what they sound like. They're for leaving a comment in your code. They're for leaving notes in your code that are not going to be evaluated by the interpreter. So I'm on a Mac, but this is a pretty universal keyboard shortcut for most editors. On a Mac, it's going to be command and then // For me, that key is going to be to the left of my right-hand shift. That's the key with the question mark and the / on it. If you're on Windows or Linux, the key command will probably be control/. If you're on Mac, it'll be command /. And this works in Replit as well. So I can select some code and I can just hit command / and it will comment it out. If I have my cursor on one line, hit command /, it'll just comment it out. I can also just throw a hash mark in front of it and that'll comment it out instead. And that's, for me, that's shift 3. Just a regular old hash mark. There's no magic there. But you can automate it with command /, and that's usually what I use because it's quick and easy. Cool. So comments are useful for leaving notes in your code. They're useful for leaving documentation. If something is not entirely obvious for how it works, you can explain like, hey, this might not seem necessary, but it is, and here's why. Or you can explain how an algorithm works, or you can leave funny jokes to your fellow programmers or yourself or something. Hopefully it ends there. Good. So what I've just showed you, another another use for these kinds of comments is if you just want to like deactivate some code, right? Like down here, I didn't want this to run every time, so I just commented it out. And instead of having this list, I just wanted to leave it in there as a note, but not delete it. So I just commented it out, and you can kind of turn on and off different parts of your code by commenting. So these are what's called single line comments. And then you have what's called multi-line comments, which are going to be done with 3 quote marks on either side. So 3 to start it off and 3 to end it. And so everything in this block is now commented out, right? And I can use single tick quotes, triple single quotes, or triple double quotes. And I do use both for different things. I'll tend to use single tick quotes just for documentation and internal comments in a program, and then I'll use double tick quotes to like block off certain large chunks of code at a time. So one trick I like to use quotes for is for code switches. So let's say there's like a block of code that I want to be able to turn off the whole thing easily without like finding the beginning and the end of where that line should be selected. I'll usually do it like this, and this line of hashes after that is just aesthetic, just so I know where the boundary is. So let me just, I'll just put a code switch around this whole thing. Okay. Cool. So now, and usually I'll leave a little note just because I'll say uncomment to d/activate. So if I comment or uncomment this, if I put a hash or remove the hash on this front line, that's going to turn off this whole block, right? And the cool thing about this is these are just 2 single line comments right now, this line and this line. But if I uncomment this out, it's going to go make a multi-line comment with this other one. So it's going to see this other triple double quote. And where else do you get to say triple and double consecutively, and it's actually meaningful. Okay. It's gonna see that, and it's gonna end the comment there. And I just put this, like I said, I put this line of hashes behind it just so it's a visual separator. I can see where the beginning and end of the code switch is. So I can turn off a whole block of code, like turn on and off a whole block of code like this. And I use this a lot in my notes file. I think Tovio is going to go over like note taking in this style. This is kind of funny because Tovio and I both arrived at this style of note taking independently. So in my notes file, you can see I have all these bits of code just commented out. Oops, this is uncommented. Gotcha. Ha. Right. And I just have all these in code switches. So anytime I'm like, oh, I was doing something, I put something in my notes like a few weeks ago, I can come in here, I can maybe like search for it, and I can say, and it's just going to activate just that little section of code, and I can run my file or copy it out or play around with it, and then when I'm done with it, I can comment it out again and do it that way. So code switches, I find them really useful. I don't really tend to see other people use them too much other than me, but I do find them really useful especially for note taking and turning on and off a block of code if you need to. And that's just a little bit about comments. Okay, cool. Let's move on. Comments are an important tool in your coding tool set. Effective comments make for better code and easy troubleshooting strategies. Here are some examples of the two general types of comments in Python. Line comments and block comments. I've always called these single line comments and multi-line comments, but you could call them line and block comments. This just shows you what I showed you. Single line comments are going to start with a hash. Any line that starts with a hash is going to be a single line comment. You can also comment something, midway through a line, or well, partly through a line, and then everything after the hash is going to be commented out. So I could put a hash at the end of this line, and I'll often do this just to leave myself a little note in line about that line. So I could say the ID of list is the same as above, right? And then that code is not going to be evaluated, or that statement is not going to be evaluated. I can just leave that note there, and I don't have to like put it on a different line. Hopefully that reading this just kind of looks a little messy, a little bloated. So I can just leave that on the same line at the end of the line, and that's pretty nice. Cool. Since I have the feeling that somebody is going to ask, you cannot leave a comment in the middle of a line and then continue the line. If there's a way to do that, no, there's not a way to do that, I'm certain. All right, if there is a way to do that, don't do it, because that could be weird. I will say, so this is telling you comments are important, and they are an important tool. It is useful to know how to use them, but don't go hog wild. A lot of other languages, like if you read a lot of C or C++ code, it's generally more comments than code. And if you're coming from another language, Python is designed to be self-documenting. It's designed around that idea of self-documentation, and that's probably, if you're coming from another language, that's probably an idea that you're familiar with Python at least. So in general, Python code, the Python language is sort of meant to be easily readable so that the code sort of speaks for itself, and that generally is true. But when you're writing production code, you don't need to use, by convention, it's not expected that you use comments. You don't need to use comments, just unless you do need them in the certain cases that you do need them. So a little note at the end of the line is fine. Some documentation strings about your functions or larger blocks of code to help you save time from like reading through hundreds of lines to get an idea of what something does. That's pretty useful, but yeah, you don't need to like comment every line or anything like you do, like is the convention in a lot of other languages. Okay, cool. Reasons for using comments. So send a message to someone reading your code. Probably that person reading your code is yourself, who you want to send a message to. It's funny, especially in the DSI or when you're doing a lot of coding in a short period of time, you'll write something or you'll go back to some code you wrote like a day or 3 ago or a week ago, and you'll look at it and you'll have no idea what it's doing. You'll be like, I'm sure I wrote this. This is in a file that I know that I authored, but it just doesn't make any sense, and you can't make head or tail of it, or you don't remember writing it. So in those cases where you think, maybe I want to remind myself what I'm doing here because it might not be obvious, play it safe and just leave a little note, just enough to remind yourself what you're doing, so you can kind of find your way around your own code. Cool. So exclude some code snippet from running. That's what I was talking about activating or deactivating, just turning on a line of code on and off. Oops, had a shortcut there. Provide function, class, or module documentation. And that's what I was saying. Like, if you have a class or a module that's really large, it's useful to leave some notes at the top, some documentation, so that way if you're looking through that or if somebody's looking through that file in the future, they can have an idea of what's in there, so they don't have to go like hunt through and like pour through hundreds or possibly thousands of lines of code to go find what they're looking for. So you can have a little documentation of what's in there. Cool. Running. Maybe they have something good to say about this. So while troubleshooting, it can be very helpful to comment out code snippets in order to prevent certain lines from running. When used in conjunction with print and type and ID functions, I would also add dir and help, dir and help to that list. This can help you, this can lead to quick diagnosis of bugs in your code. So it's not uncommon, and it happens to me and other experienced developers that I look up to, that it's not uncommon that you write some code and it doesn't do what you thought it was going to do, or you got an error or something, and so you start to think of creative ways of going, okay, something, I'm making some assumption somewhere that isn't panning out. It's doing something different than I thought it would. So you can use comments maybe to deactivate a section of your code, to test something out, and you can use print, type, and ID, the print function, the type function, and the ID function to kind of get information about different parts of your code. What's this value at this point? What's the type of this value at this point? Maybe the ID changed, or maybe it didn't change and you do need it to change, that kind of thing. So yeah, so and comments are just part of that flow, part of that structure of debugging in general. It can be very useful for that. Providing documentation. So here's an example of a doc string for a function, and you'll see a lot of functions have this in any large production environment. You'll see a little doc string on the function, and that'll give you a quick idea of what that function does, right? So this says it returns, so reverse a string returns a reversed version of the input string is how I would word that. But so this is a description. Then this is a very standard format for a documentation string, where you'll see a little description, and then it'll talk about the parameters, what its inputs are. So it says the parameter is called input stir, which is a stir, means it's the type of data that it is a string, and just describes that really quick. It's going to say the string to be reversed. And if it had another input, in this case this function only has one argument. If it had another argument, that would be listed just immediately below that. And then it'll talk about what its output is going to be, i.e. what its return value is going to be. So it says it's returning a reverse string, and its type is string, and it says the result of reversing the string, the input string. Cool. And then you have your code, your proper logic here. So it's nice to have spinning wheel of doom. Why? I can't use Chrome. Okay, now I can use Chrome again. Good. Lovely. Here's an example of a text editor automatically generating the doc string for this function in a pop-up when hovering the cursor over the name of the function. Yeah. So I think this is from VS Code. VS Code will give you this little pop-up, and you can see it actually, it knows where to highlight, and it knows how to highlight because of this underline. thing that's happening there. So this is actually following format your code in that way. There's another way to take advantage of this. Yeah. Oh, I know. I'll comment it out. I'm like, I gotta get rid of that. But we'll actually use these comment switches. I like to use these while I stream or teach because they make it a little easier. Don't have to delete stuff. Okay. That is commented. So let's say I have this function def my function takes arg, returns run, returns arg plus 3 or something, I don't know. Add 3. We'll call it add 3, takes in a num, just rewriting everything, and it returns num plus 3, right? So obviously this is so small we don't really need a docstring for it, but here's something. If you're not working in a text editor that has pop-ups like this, and I mean it's my preference and personal recommendation to remove that stuff because I think it actually is kind of frustrating, but if you're like me and you disable that functionality in your, so let's say this is a function from some module somewhere and I don't necessarily want to go like pour through the module to find the function and read the docstring, and I have those pop-ups disabled, I can, or actually instead of print, I'll do help, add 3, right? So we're going to look at it, since it doesn't have a docstring, we're going to look at it without the docstring first, and then I'll put a docstring in it and we'll look at it then. Just imagine that it's actually a meaningfully complicated function. Oh, wait, why do I not just copy this function? I'm going to just copy this function. It was way easier. Okay. Cool. This add 3 example is kind of garbage. So I'm going to paste in that reverse the string example. So let's look at help for reverse string, and I'm actually just gonna, I think that's actually gonna give me help on string. Now I'm curious. Now I must know. Use help to get interactions. Okay, yeah, so it actually, because it gives us the output. So when you're getting help, when you're using the help function for another function, you just actually only pass the function's name. You don't do parentheses, and you don't do the input. You just do the function's name. So if we get help on this without a docstring, then we get to wait for the code to load, which is kind of annoying. Okay, it loaded. Let me switch back. So you can just see it just gives us the name of the function. It's not very helpful. It does tell us the name that it calls its input, which I don't know, maybe that's helpful, but it's not real helpful. But if we have a docstring, we have a docstring, and the docstring has to be the first thing. So now you can see help gave me help actually gives me the doc string. So it says reverses a string, and it tells me about the parameters, and it tells me about what it returns. So now that's pretty useful. Cool. And then to get out of help, you hit Q for quit. It's a little bit antiquated, but if you're like me and you want to use just a plain text editor without the pop-ups and the you want to use your terminal, you can use the help function to give you those little tidbits. I'm sure under the hood, this is using the help function to do that or something similar. Cool. Okay, to-do statements. Occasionally, you may realize you're going to need a helper function later on, or you have an idea or later. You can use a to-do. So notice this syntax highlighting actually takes special note of to-do because it's a pretty formal thing, right? So nope. Let me do this. There we go. Okay. That's better. So let's write a to-do. So let's say I'm going to write like a def let's say I'm going to write like an isPrime function. I'll say to do, and my syntax highlighting does not highlight it specially, but this is still a formal thing. It doesn't do anything special in your program, but it's a convention nonetheless. Implement isPrime function. And then I can say def isPrime, and we'll just throw a pass in this. We won't even worry about the argument for now. Cool. So you might also want to leave reminders for yourself to fix or improve existing code. So in this case, find a better way to reverse your string. And there are different, this is such a standard convention across languages, there are different like programs and extensions that you can get that will like help you aggregate all your to-dos. I don't use any such extension myself, but I have in the past a long time ago, and they were pretty neat. I didn't need them for my own work, so I didn't continue to use them, but if that's something that you want, it's there. Cool. How should you not use comments? To provide function documentation to describe each line of code for future readers of your Python script, that's the current winner. To briefly explain why you made a particular algorithmic choice. This is a good reason to use a comment. Or to disambiguate a particularly dense line of code. Those two are kind of the same. So I'm going to go with to describe each and every line of code for future readers of your Python script. It's, I guess, the C thing, kind of. Good. Looks like there's only one challenge there. Nice. And I did it. Okay, print. Oof, I've been using print. Sorry about that. So by the end of this lesson, you'll be able to describe and use the print function in Python. So I'm going to just describe it real quick. So print shows you in the terminal, it just prints to the terminal whatever you pass to it. Let's do this. So print. print whatever I give to print, it's just going to show it to me on the terminal. I'm just saying, hey, I want to see this. I actually want to see this thing. So if I say hello world, hello, I'm going to be all formal about this. Hello world. And run it, we will see hello world printed whenever IPython wants to actually finish executing my code, please. Says that I want to see that, right? So if I say var equals, or let's say hi equals hello, right? And then I put a print underneath it or something, right? This is not going to do anything unless I put the variable in it, right? So whatever's in those parentheses is going to be displayed in your terminal, your running environment. So the print function simply takes the value passed to it and writes that value to the console right here. Okay, input. I don't want to talk about input yet. Yeah, I'll talk about input. Okay, so should I say related to the print? Is it related? It's sort of, yeah, I guess it's kind of related. So print gives output to the console. If you want to take input from the console, you use the function input, right? So let's just use, let's say hi takes in input, and we want to prompt the user with a message so that they know what input to give. So I'll say, please, what's your name? And then say hi will print, or print will print say hi, which receives its value once input is completed, plus the phrase hello. Actually, I should do that in the other order. What am I doing? Let's call this name, because that's what it is, name. So name equals input, what's your name? And then it's going to get a string from input. Input always, always, always returns a string. You can, if you want a number from it or something, you have to cast it as a number. And then you can print that string. Yeah, so let's run our program. I have no idea how long this is going to take because my interpreter is being super slow. Oh, I didn't even save it. Try that again. So this will say, what's your name? I'm going to put in my name, Clark. And hit enter, and it's going to say, hello, Clark. And I forgot to put spaces at the end of the thing because that's what happened. We'll just do it again, just so you can see it done at least decently. What's your name? And it says, hello, Clark. Cool. So the input function accepts character input from the keyboard and prints the message it is passed. Above is simply taking input from a user and displaying the input back to the console. But with input, we need that little prompt there because that helps the user know what what they should input. See what's happening in your code. Said that weird. See, when writing code, the print function can be very helpful in showing you the value held by the variable. Okay, so print shows you the value of a variable, or it shows you just a value that you pass. Anything you pass to print that has a value that can possibly be resolved as a valid value by Python, if you pass it to print, it will print the value. It will display the value. So let's look at this more. Or I guess, yeah, here, let's do this. This was really more about input. So we could even print the value of print. So print with no parentheses. And it is just to show you that you can print stuff, and you should just be like, always think about what can you print. Just print everything all the time, and you'll see a lot of things that you maybe didn't know you'd see. So it's useful. So print without the parentheses is, it says built-in function print, right? It just tells you that it's the built-in function called print. With parentheses, it's going to be we'll do that. So you can see this inner print still ran. It says inner print, and then the value of inner print is actually none, right? So that is an important thing. That'll come in handy in the future. When we get into functions, remember that the functions have a thing called return, and that tells you what the function output should be. And it's easy to get, since you're usually like printing off the function itself after you write the function, you invoke it. It can be easy to forget that print is not the same as return. So we'll be revisiting that very concept often, but for now, just planting that brainworm. Print is not return. Okay. So when writing code, the print function can be very helpful in showing you the value held by a variable at a given point of execution, along with the type function and ID functions. Print is a valuable tool for verifying that your code is behaving as you intended. So here we can monitor how the variable y changes in value by sprinkling some print statements into the code in various places. So we have y equals 4. It's pretty straightforward. Y times equals 21. So that might be a little funky to think about at first, but we can just print it off, and we don't even need to think about it because that'll just show us. All right, so that does translate to y equals y times 21. So that's 4 times 21, and that'll give us 4 times 21, 84. And y equals int of 84 over 7. That I cannot do in my head. And we can see what that's going to be. And that's the nice thing. And I encourage you all to do this. I notice a lot of people, especially when you're starting off, thank you. If you've heard me give any lecture at all, you've probably heard me say this, that when you're first starting off, it can be easy to say okay, I'm gonna do really good programming, and I'm gonna really understand this, and I'm always gonna think really hard about my code. A lot of academic fields kind of demand that, you have to go in and really do the all the mental work yourself, but there is somewhat of an exception with programming, because you have the computer, right? The computer will tell you, like, I'm looking at this and I'm like, I don't want to divide 84 by 7. I don't want to, like, see what that's going to be. But the good thing is, I'll just grab all this. The good thing is, drum roll, I don't need to do it in my head because I can just run my code. So I encourage you, if you get to something like this and you're like thinking through it, just run it and print something off, put your eyes on it. That's usually more valuable and quicker way of getting things done than trying to think through everything. You can get Python to think through a lot of things for you, so it's a nice thing. Okay, so we see 84 right over here, and then integer of 84 over 7 is going to be 12, right? And that's a nice clean number because we cast it as an int. Cool. Printing challenge. Lag, come on. What will this code snippet print to the console? X equals 3, x times 12, x minus 14. I'll give you a second to think about this. I'm not sure how much latency there is, but if you're watching and you're in the thread, go ahead and post your answer. I'll just give you a second to think about this. X equals 3, x times 12, and x minus 14. Then we print x. So what is the value of x that's going to be printed? It's going to be 3, right? So notice the value of x hasn't actually changed from its initial value of 3. So this is a little bit of a curveball. So this is not times equals, this is not minus equals. We're not asking for x to change, we're just making an expression, but the expression doesn't get saved in x or anything, actually. If these are just like expressions in a vacuum. They happen and then nothing's done with them, nothing captures them in a variable or anything. They're not printed off, they're just expressions. So x equals 3 is the only persistent line of code here, right? It's going to persist, and we can say print x and we'll get 3. Cool. Okay. What will this code snippet print to the console? Y equals 5, print y times 5. Y equals 25, print y. Give me a second to think about this one too. Oh no. Okay, so let's print off 25 and 25. So we have y equals 5, print y times 5. So 5 times 5 is 25. Y equals 25, print y is 25. So that'll be int 25 and int 25. Okay. This is an interesting one, right? So what will this code snippet print to the console? So z is 21, z plus equals 3 is 24 over 8 is 1, 2, 3, 4, 6, 7, 10, 11, 12. That's going to be 3.0, and then z squared is 3 times 3 is 9, z equals z plus 3, so it's 12. 3, oh, that's 3z, so that's 9 times 9 is that 81? Oh, no. I'm just being, so that's 27 plus 9 is 36. Whew. Okay. So this line, z is 36, right? This line, z is 3, so we should get 3 here. But remember, we have single slash division, so that's going to be a float. So we should get 3.0 there. So all this stuff that happens to z afterwards, that doesn't affect what the print is here, right? This is just going to tell us what z was at this exact point. Whereas these ones, it doesn't tell us like the ultimate value where z is ultimately going to have whatever value it's going to have. It's just going to tell us the value of z at a certain point. Indentation. So by the end of this lesson, we'll be able to describe how Python interprets indentation. Line endings. Some languages use specific line ending symbols to denote the end of a line of code. Block means something different. For example, Java uses curly brackets to enclose the code block, and semicolon to denote the end of a statement or a line. So Python, by contrast, does not use either of these conventions. The end of a statement in Python is simply the end of the line, and the end of a block is where the code becomes unindented to a previous indentation level. We'll get to that in a second. And interprets this as the end of the statement and moves on to the next line. Not quite a warning, but more of a note, just so you know. Technically, the semicolon symbol can be used to denote the end of a line statement in Python, but it's unconventional and arguably a bad practice, as shown below. So you can do this. You could jam these two lines onto one line like this with the semicolon, but this is not conventional in Python. And I would say it's bad practice. So the Python interpreter actually will go in and it'll put in the semicolons in all your code. This is another one of those sort of syntactic sugar things, right? It's syntactic sugar that we don't have to put these in, but the interpreter is smart enough to figure out where to do that. Python correctly interprets the line below as two separate statements. Yeah, okay. Blah, blah, blah. So there's a time and a place for using semicolon to separate statements, but in general, it is best for readability if your statements are each on their own lines. All right, indentation. So this is, I should read this first. At its core, Python. See if I can get all the words in the right order this time. At its core, a Python script is simply a sequence of instructions to be executed in order. In order meaning from top to bottom. The instructions above are executed before the instructions below. So instructions can be comprised more complex, made up of groups of statements or blocks. Excuse me. Okay, so def divisible by 3 or 7. This is an example of a function. We haven't really gotten into covering those yet, but this code will, if it doesn't quite make sense yet, it'll make sense soon. What a function allows you to do is write some piece of code that you're going to use multiple times, write it once, and then utilize it multiple times by invoking the name that you give it. So def, the purple keyword def, tells us that we're going to be defining a new function. This is an arbitrary name. We can give it whatever name we want to give it, just so long as it's not already a name of another function or a built-in keyword or something. There are a few things you can't call it, but by and large you can call it whatever you want outside of those things. So this says divisible by 3 or 7. I assume this is going, oh no, it's going to return anything. So it's just going to print out whether the number is divisible by 3 or 7. So this just takes in a number. This just says the input for this function is some number. And we're going to check the input, that n right there. It's kind of like a variable, but it's called a parameter in this specific context. So if that parameter n mod 7, so if the remainder of n over 7 is 0, this code is incomplete. No, actually that's just a weird oh, sorry. That was just a different way of writing that than I was expecting. So this is saying if the remainder is equal to the remainder of n over 3, and they're both equal to 0, then it will print the number is divisible by both 3 and 7. Else if the number is over 3, the remainder of the number over 3 is 0, then we'll print the number is divisible by 3. Else if the number over 7, the remainder of the number over 7 equals 0, then we'll print the number is divisible by 7. Else, meaning if everything else was false, if all of these other conditions did not execute, then we will print the number is not divisible by either 3 or 7. Okay, so notice how all of the code below the function's definition is indented. Yes, that's why. Oof, I ahead of myself there. So all this code here is indented inside the function. And that is necessary. That is syntactically significant. There's a few places where I've said, well, you can do this and it's not going to change your program. This is necessary. It can be kind of funky because it's invisible characters, right? But it is syntactically essential. Oh no, I want to start the dictionary. It's syntactically essential for the program to work correctly. So let's just look at this in an actual environment here. Oh man, oh, why can't I use my computer today? Okay. So def divisible by 3 or 7 takes in n, blah, blah, blah. we know what this is going to do. So if I call this, and I'm actually going to just call this down here, and let's 7 is divisible by 7. Let's give it a 2, that'll be divisible by neither, and a 12 will be divisible by neither. And let's see, 21 will be divisible by both. Good. So we're going to wait for that to run. We'll just see this work correctly, and then we'll play around with the indentation. Cool. This is what we expect to see. I'm actually just going to pare that down to one function call for now. And then let's see what happens if I change the indent here, right? So you can see I actually lost my syntax highlighting. Like even my environment syntax highlighter is just like, that's not right. We'll see what happens. We're going to get an error. I think it'll be a syntax. No, it'll be an indentation error. Okay, so this says indentation error, and it points at this line of code. If inmod 7 equals inmod 3 equals 0, and it says line 80. Let's look at line 80. There's that line of code. And it doesn't like that, and it says it's an indentation error, and it tells me it expected an indented block. Okay, so let's indent that, right? Guess what's going to happen. Expecting an indented block, it's pointing at line 81, next line of code, right? So the if also expects an indented block, right? And I'm just going to indent the rest of these, right? So what happens, the other thing, Python's still not going to know what you mean, right? So it is actually valid to indent something one single space. You can actually do that. This is fine, right? This is legitimate code where I have a single space indent, right? I just use a single space in front of these lines. This is valid, but it's not, I mean, I don't know about you, but I don't find it pleasant to read. It's kind of funky looking. Sometimes you will see two space indent, but you can see that, like, as soon as I make the indent irregular, it's, well, in this case it's working, but I think we are going to get an error here. Yeah. It's mad about this elif because it thinks that this elif is indented inside the if, and it actually needs to be on the same level, right? So just make sure your indentation is consistent. And this is just kind of on you. Like, this is valid code in this case, but we have two space indent on these lines, and then, like, let's do, let's do 2, 3, 1, or that's 1, 2, 3, 3 space indent on this line, and then 2 4 space indents on this line. So this would work, but man, it's ugly. So what we want to do is, I'm just going to say, just use a 4 space indent that is standard according to Pepe, and it's gives you enough room that it's nice and readable and it's clear when things are indented. So it can be kind of funky, and you will develop an eye for how things, and a feel for how things need to be indented. But it is important in Python to get it right. Cool. All right, we're right at the end of study hall time. I think I just want to get through this, and we'll call it good. Okay, this is talking about the convention. If you want to read this link, that's a good place to go. I imagine it's going to take us to PEP 8. Excuse me. Oh no, python.org. But this is going to talk about the official, oh, this is the PEP 8 style guide, yeah. The official statement on how to use indentation. So this says use 4 spaces per indentation level. Continuation lines should align wrapped elements either. Okay, well this is kind of talking about something else. But this is just basically what I was saying is you can use 4 space indent. And it'll know what you're talking about. Cool. Da, da, da. So specifically cites 4 spaces as the correct indentation increment per level of incrementation. I agree wholeheartedly. Each indentation level will correspond to some level of scope. Consider this snippet taken from the code above. I think they're just kind of going to walk through what I showed you. All right, let's just jump into the challenges. Indentation challenge. Will this code run or will it result in an error? Think about that for a second. Will it run or will it result in an error? So, well, it is indented. It's all indented inside the function. So this is indented, what is this? 1, 2, 3, 4, 5. That's 5. It's not conventional. And then this is not aligned on the same level. So Python looks at this and thinks it's like unindented or dedented from the other line here. But its line is the scope that it creates is indented, and that would work as variable declaration are the same. So I had already answered this one before. It says, no, the code will not run, or no, this code will result in an error. Will this code run or result in an error, right? So have we gone over, I don't think we've gone over if statements, right? So if and else go together, right, and they need to be on the same indentation level. You can't just have an else just floating out in the middle of nowhere, which this one is. It has nothing to do with this if it's indented. So this else would need to be dedented to be in the same indentation level as this if in order for this to be valid code. So this will also result in an error. And then this code is valid. It's going to run, it's going to do what it says it's going to do. But until you look at this line and you realize there's no preceding if related to this else, right? That looks bad, but something to keep in mind with indentation, if your code looks nice, it's a good indicator as to whether it's going to be valid or not. If you're looking at this kind of like shaky, kind of like messy looking code, and you're gonna like you're kind of thinking like, I don't know if it'll be good enough, kind of, it's probably not going to work, especially regarding indentation. Python's very sensitive about the indentation being consistent, which is a good thing. It enforces, I think, I like it because it kind of forces you to write good code. Cool. Oh, 1 second here. Waiting on this thing to load. What is going on? Okay. Do we have time for this? Yeah, that's a good one. Let's do this last one. So by the end of this, you'll be able to write a simple function and explain why functions are important. So I just touched on this briefly a bit ago. The utility of functions are they allow you to write code that you intend to reuse multiple times. They allow you to write it once and use it as many times as you need. They also just kind of, once you start doing that, it makes things cleaner and easier. Makes your code feel more organized. So yeah, I like writing my code in functions. So functions can be thought of as ways to create repeatable procedures. So you define an algorithm and you can repeat it or invoke it. Take the modulo by 7. If this operation must be performed multiple times, it might make sense to just write a specific function for that purpose. This function will be stored in memory, and it can be invoked and reused repeatedly. See this REPL. And experiment with example. Okay, cool. So, like the copy said, right, there's no specific operator that multiplies something by 3 and then takes the modulo by 7. But we can define that procedure. We can say def times 3 mod 7 takes in some number as its input, and it's going to return, meaning it's going to give us an output of some number times 3 mod 7, right? And this is a small operation. You might just do that every time you needed it, but in this case, this just gives us a small example of a function. And you can see it sort of makes it a little cleaner and easier to read. We can make our code sort of more semantically meaningful with these functions. So this procedure is encapsulated by the times 3 mod 7 function. As such, it cannot be altered without altering the result of all the calls to that function. Printing versus returning. So remember, printing is not the same as returning. So notice, let me actually write a function that returns something. I'll show you. Okay, so let's do def greater than 10, greater than 10, takes in a number, and if num is greater than 10, return true, else return false. Right, so here's an example. This function is just going to return true or false, whether or not the number we pass is greater than 10, right? And this is another just simple sort of useless function. And this could be written even shorter if you're thinking that, but I just wanted to give us a few lines to work with. So we're going to print the function call, right? So wherever this function is called, this will give us wherever this function is called will literally evaluate to the value that it returns, right? So if I run this, we should if it runs. So false, true, and false. 10 is not greater than 10. It is equal to 10, so it's false. And that's the check that we're making, right? So it's kind of funny. So if I wanted to add 10 if greater than 100, right? So if the number is greater than 100, we'll return num plus 10. Yeah, okay. If it's less than 100, we'll just return the num. So we'll make this 300, and these two should just get the num back. So this first one should give us 310, and this other one, these other two should just give us the inputs, right? So I can actually think about this whole thing. I can think about this as, even if I can't infer, you know, by looking at it what its output is going to be, I can think about it as its output. So I can say minus 200 from that number and just do whatever I want. So we should get 110 out for that one. Cool. All right. So yeah, so that back to printing versus returning. Printing shows you a value. Returning gives a function an output, right? So some of y'all are going to do this, and this is fine. But you're going to submit some code that's like this. Right? This function has no output. No output, right? The tests in Learn are expecting functions that have output or print, right? And you have to pay attention. Does this function print something, or does it return something, right? And there's a difference, very big difference. But since we're often writing functions and then printing the function itself, it can kind of seem like, well, you return something and then you print it, so why not just print it instead of returning it and then printing it, right? So this will give us an error because we can't subtract an integer from a none type, which we're doing here. I just want to show you the output when we have no output, right? So we don't have any output. This function doesn't have an output. So what are these going to print? So you see, we see 310, none, 33, none, and 10, and then none, right? So the reason we're seeing the correct answers, the answers we expect, is that we're printing them off here. The reason we see none is once this function is concluded, the value of the function is then printed, and it doesn't have a value, so Python assumes that it returns none. So if a result of a function is not specified, if the return is not specified, Python will assume that you mean, will assume that the function has a value of none, right? Okay, so return 2x, this is sort of an example of the functions that I just wrote. Takes in x, and it's going to return 2 times x. And then we will print the whatever that returns, right? So return, I mean, really makes the function useful. Not all functions do have a return. Some don't. I would say a vast majority will have a return. They will return something. So probably more often than not, it's safer to. Cool. So it is necessary to call print with the result of return 2x. Oops, is that? In order to actually see the result. Only returns the value of x multiplied by 2. It does not make it, the function by itself does not make it visible on the terminal, right? So we want to see the result of that function. We need to make it visible on the terminal. X multiplied by 2. It is unnecessary to call print with the output of the print 2x function because print 2x calls the print function itself. So then what happens if we call print 2x 3? And I gave you an example of this earlier where we printed print in the print. We work out of a proper environment. Nothing against the Learn environment, just it's nice to work out of a regular text editor, install VS Code. But if I find a function called mod5 times 6, the function should take a number as an argument, perform the, I was misreading that, multiply the result by 6, then return the new result. Okay, cool. So I'm gonna need to pick my way through that. What I like to do is just pretend like this is my doc string. There's the problem statement. Oops, why is that not? What? Weird. Huh. That's a weird. I'm having some like syntax highlighting. Oh, that's why. Duh. I have to actually finish writing this line. Okay. So takes in a num, and there we go. Okay, sorry about that. So define a function called this. The function should take in a number as an argument. So there's our parameters section. And I'm not structuring this exactly like the and then return the new result. So return the new result is going to be return the result of return the result of the operation modulo by 5 multiply the result times 6. I'm going to do this. Okay, there's a nice clear doc string. All right, so we can do we'll say result res for now is fine. Res equals num mod 5 times 6. Good. And we can return res. Right, now I want it 5 times 6. Mod 5 times 6 is, we'll say 15, or 25, fine. Slow term on modulo 5. Oh, right. Right, because modulo 5 mod 25 mod 5 is 0. So let's actually do 23. So 0 times 6 is 0, so that's why we got that. Cool. Well, this should work. Let's just submit it. No. Notice I don't have to submit the print. That's just there to test the code. Run notification. We'll do that. Cool. Now, notice I'm only using res one time here, so I can actually just use it in the place, use its value in the place that I'm using res. So we're just gonna, oh, okay, fine, we'll do it this way. We're just gonna return res like that. And that'll give us the same thing. Cool. Your first function challenge. Okay, I think this is a good place to wrap up. We've gone about an hour, which is, or about 2 hours. And I want to give folks, if you're watching and this is a challenging spot, I think I want to give people a chance to go through this, and we'll just pick up